Welcome back to Quadratic Equation from Mathematics Educational Academy. This is continuation class of exercise 4.2. It's a continuation class of exercise 4.2. Now we did it last time. We did it up to question number 1 and also 2. Now we are going to start question number 3, quadratic equation, exercise number 4.2, class 10 by Mathematics Educational Academy. Now question number 3, find the two numbers whose sum is 27 and product is 182. Sum is 27 and product is 182. Now solution. Let one number be x. Let one number be, say, x, and second number be y. Second number be y. Then according to the question y is equal to x plus y is equal to 27 or y is equal to 27 minus x. This is a equation 1. So according to the question, again, product of the two numbers is 182. According to the question, product of two numbers be 182. That is xy is equal to 182 according to the question, equation 1. According to equation 1, we have, according to the equation 1, we have, in the equation 2 becomes x into 27 minus x is equal to 182. X into 27 minus x is equal to 182. And further simplification, 27x minus x square is equal to 182. 27 minus x plus x square is equal to 182. Now 27 into x minus x square is equal to 182. That implies x square minus 27x plus 182 is equal to 0 is equal to 0. That implies when factorizing with Middleton by using the Middleton splitting method, the 27x becomes 13x plus 14x. 13x plus 14x. You could have studied the factorization method in NCERT Class 8 and 9. Now, using the factorization method, Middleton splitting factorization method, x square minus 13x minus 14x plus 182 is equal to 0. Then further simplification, taking x as a common from first and second term, x minus 13 and 14 is a common from third and fourth term, 14 x minus 13 is equal to 0. This is by using Middleton splitting method. That implies either x minus 13 or x minus 14 is equal to 0. That we can write it either x minus 13 is equal to 0 or x minus 14 is equal to 0. That implies x is equal to 13, then y is equal to 14 or x is equal to 14, then y is equal to 13. This is the required answer for this question. Now coming to the question number 2. Find the two consecutive positive integers whose sum is find two consecutive positive integers whose sum is find the two consecutive positive integers sum of whose squares is 365. Sum of whose square is 365. Let two consecutive integers. Now let solution. Let two consecutive integers, let TW2 consecutive integers be x and x plus 1. According to the question, therefore, according to question, x square plus x plus 1 whole square is equal to 365. That is, sum of whose squares is 365. Here sum of whose squares is 665 given in question number 4. Now according to the question, we write once again here x square plus x plus 1 whole square is equal to 365. That implies x square plus x square plus 2x plus 1 is equal to 365. That implies 2x square plus 2x minus 364 1 minus 365, that equals 364 is equal to 0. That implies taking 2 as a common, x square plus x minus 182 is equal to 0, or x square plus x minus 182 is equal to 0. Then further simplification, we will get x square plus 14x minus 13x minus 182 is equal to 0. That is middle term splitting method, factorization by middle term splitting method. That implies x, we take it common, then x plus 14, then now 13 you take it common, x plus 14 is equal to 0. That is x plus 14 x plus 13 is equal to 0. That implies either x is equal to 14 minus 14 or 13, but x cannot be negative, x cannot be negative. Oh, this is negative, so x is equal to 13. X is equal to 13 is one number, and the second number x plus 1 is equal to 13 plus 1, that is x is equal to 14. 13 plus 1, then x is equal to 14. So which is the required answer for this question. Now coming to question number 3. Question number 3. Question number 5. Now coming to question number 5. This just we are arranging the questions in order. Question number 5. The altitude of right angle triangle is 7 centimeter less than its base. If the hypotenuse is 13 centimeter, find the other two sides. This is question number 5. Question number 5. The altitude of right angle triangle. So according to the question, we draw triangle solution. Let ABC is a right angled triangle. ABC is a right angle triangle. So this is right angle triangle A B C. So BC is equal to base. AB is equal to altitude, and AC is equal to hypotenuse. Hypotenuse. Now according to the question, BC is equal to x centimeter, and AB is equal to x minus 7, that is 7 centimeter less than base. It is given, so x minus 7 x, and this is, and hypotenuse is 13. So AC is equal to 13. Now since according to the question, since his altitude is 7 centimeter less than the base, using the Pythagoras theorem, Pythagoras theorem, we have, using the Pythagoras theorem, we have x square plus x minus 7 whole square is equal to 13 square. Then further simplification, it is x square plus minus 14x plus 49, x square minus 14x plus 49 is equal to 169 is equal to 169. That implies take 2 as a common, 2x square minus 7x, 2x square minus 7x. Before that we simplify the above equation. It becomes 2x square minus 14x minus 120 is equal to 0. 2x square minus 14x plus 49 minus 169 is equal to 0. Then when you simplify further, 2x square minus 14x minus 120 is equal to 0. Then further simplification, 2 into x square 7x minus 60 is equal to 0. Again that is equal to x square minus 7x minus 60 is equal to 0. That implies when factorizing the middle term method, x square minus 12x x square minus 12x plus 5x minus 60 is equal to 0. X square minus 12x plus 5x 60 is equal to 0. That implies take x as a common, x minus 12, then here 5 as a common, x minus 12 is equal to 0. Is equal to 0. X, to take it common, x into x minus 12 plus 5 into x minus 12 is equal to 0. Then further simplification we get x minus 12 x plus 5 is equal to 0. That implies x is equal to 12 or minus 5. Since x is the base, then it cannot be negative. Since x is the base, it cannot be negative. Therefore the sides of the triangle are x is equal to 12 and x minus 7 that is 12 minus 7 is equal to 5 centimeter. 12 centimeter and altitude is 5 centimeter. This is question number 5. Now question number 6. Question number 6. This is the question number 6. A cottage industry produces a certain number of pottery articles in a day. It was observed on a particular day that the cost of production of each article was 3 more than twice the number of articles produced on that day. If the total cost of the production on the day was rupees 90, find the number of articles produced and the cost of each article. This is the question given under question number 6. Now we write a solution. Let the number of articles produced in a day be x. Let the number of articles produced in a day be x. Then according to the question, then according to the question, the cost of production of each article was 3 more than twice the number of articles produced on that day. That is the cost of production of each article in rupees was 3 more than twice the number of articles produced on the day. This is given in the question. Now total cost of production on a day. Therefore the total cost of production on a day is equal to x into 2x plus 3. This is according to the question. Also, the total cost of production of the day. Also, the total cost of production. Total cost of production. Total cost of production on that day is equal to rupees 90. Rupees 90. Therefore, according to the question, 2x square plus 3x is equal to 90. This is from equation 1 and equation 2. This is by equation 1 and equation 2. By equation 1 and equation 2. Now further simplification by splitting middle term method, we will get 2x square plus 3x minus 90 is equal to 0. Then further simplification, 2x square plus 15x minus 12x minus 90 is equal to 0. That implies 2x plus 15 minus 12 Now we simplify taking 6 as a common. 2x plus 15 is equal to 0. 2x plus 15 is equal to 0. This is question number 1. The equation according to the question we simplified as taking x as a common. 2x plus 15 minus 6 as a common for the fourth term. This becomes like this. Now further simplification, we get that is equal to 2x plus 15 into x minus 6 is equal to 0. That implies either 2x plus 15 is equal to 0 or x minus 6 is equal to 0. That is equal to, when 2x plus 15 is equal to 0, x is equal to minus 15 by 2. When x minus 6 is equal to 0, that is equal to x is equal to, or x is equal to 6. So hence number of articles produced is not negative. Then x is equal to 6 is our required number. Therefore, or hence Hence, number of articles produced is equal to 6, and cost of each article is equal to 2x plus 3, that is 2 into 6 plus 3 is equal to 15. That therefore cost is equal to rupees 15 for each article. Now this is end of your exercise 4.2. Now before starting exercise 4.3, let us discuss theorem part of exercise 4.3. Now first one, quadratic formula. This is very important formula for all type of quadratic equations. Now consider the quadratic equation. Ax square plus bx plus c is equal to 0. If here a is not equal to 0, suppose if a is equal to 0, there is no existing of this term. Once there is no existing of ax square, then this is not a quadratic equation, then it is a linear equation. To make this equation as a quadratic, definitely a must not be equal to 0. Now ax square plus bx plus c is equal to 0. Dividing throughout by a, we get, when you divide with this with a, numerator of a and denominator of a cancel out. Similarly b by a, x plus c by a is equal to 0. The further simplification, x square plus b by a x is equal to minus c by a. This place c by a comes this side, becomes minus c by a. Add squares of half of the coefficients of x, that is coefficient of x is this b by a is the coefficient of x. Half of the coefficient of x, b by 2a. b by 2a is the half of the coefficient of x, that is b by 2a whole square. Now add square of half of the coefficient of x. So half of the coefficient of x b by 2a and its square is b by 2a whole square on both sides to obtain quadratic formula. X square minus plus 2 b by 2a x b by 2a whole square plus b by 2a whole square minus c by a. This is a simplification of this equation by adding square of half of the coefficient of x. Now further simplification, x plus b by 2a whole square, then b square minus 4ac by 4a square. This is a simplification of this equation. Take square root of both sides to we get x plus b by 2a. The square will go this side, becomes a square root of right side of the equation. Then further simplification, we get minus b plus or minus b square minus 4ac by 2a. So roots of the quadratic equation ax square plus bx plus c is equal to 0 are minus b plus root b square minus 4ac by 2a and minus b minus root b square minus 4ac by 2a. This is the splitting of this equation. That is, b square minus 4ac is greater than or equal to 0, then this value exists. Also, b square minus 4ac is less than 0, the quadratic equation will have no real roots because there is no negative underneath the root of any value, any root. This should be positive value. Negative values are not acceptable, are not possible to derive by root of any equation. The quadratic equation will have no real roots when b square minus 4ac is less than 0. Since there is no negative value of roots exist, therefore b square minus 4ac must be definitely greater than or equal to 0. When there is this b square minus 4ac is greater than 0, then only the equation will exist. Otherwise, this becomes 0 and this becomes negative, this becomes negative, the solution is not real. Now, so ax square plus bx plus c is equal to 0 are given for x is equal to minus b plus or minus root b square minus 4ac by 2a. This is the formula to find the roots of quadratic equation. Roots of quadratic equation is also known as quadratic formula. This is the very important formula for under quadratic equation. So x is equal to minus b plus or minus b square minus 4 root b square minus 4ac by 2a is a quadratic formula. It's very important. Now coming to next, nature of roots. Nature of roots. Consider the quadratic equation ax square plus bx plus c. This is the quadratic equation. For this quadratic equation, x is equal to minus b plus root d by 2a. What is d here? D is equal to 4 b square minus 4ac. This is the d value. Similarly, beta is equal to minus b minus of root d. This is plus of root d. This is minus of root d. Like here, we have plus side plus of quadratic formula and minus of this quadratic formula. In the same way, instead of b square minus 4ac, we written d as a representation. And then it is represented in form of alpha and beta. Now here d is called discriminant of quadratic equation. Discriminant. If d is equal to b square minus 4ac greater than 0, you see d is equal to 4 b square minus 4ac is greater than or equal to 0. Here we can split in two ways. One is greater than 0, other than one is equal to 0. That is b square minus 4ac is greater than 0 or b square minus 4ac is equal to 0. Now we will take b square minus 4ac greater than 0. Then alpha and beta are real. Alpha and beta are real. Also, x alpha minus beta is equal to root d by a, which is not equal to 0. Then alpha is not equal to beta. The discrimination of quadratic equation can be shown in three forms given below. One is greater than 0, other is equal to 0, third one is less than 0. When b square minus 4ac is greater than 0, then alpha and beta values are different. They are distinct roots. We call alpha and beta are the distinct roots for this quadratic equation. When is equal to 0, alpha and beta are the same. They are real roots. Both are having minus b by 2a. In the case number 3, b square minus 4ac is less than 0, which is negative. That is, there is no equation, there is no existing of the quadratic equation, there is no real roots for this quadratic equation. This is a very important concept under nature of roots. Now question number exercise 4.3 will use this formula nature of root quadratic equation concept here, and we try to solve these questions under 4.3. Now question number 4.3. This question number 4.3. Find the exercise number 4.3. Find the quadratic equation. Find the quadratic equation. The nature of the roots of following quadratic equation. If the real roots exist, find them. First of all, we will decide whether real roots exist or not. Real roots exist or not. Then after that you finalize values of that x. Now first of all, find out whether this equation is having the real roots or not. Now solution. We have given 2x square minus 3x plus 5 is equal to 0. Comparing the equation with the quadratic equation, comparing given equation with the quadratic equation, that is ax square plus bx plus c is equal to 0. We get a is equal to 2, b is equal to minus 3, and c is equal to 5. So d is equal to b square minus 4ac, that is minus 3 whole square minus 4 into 2 into 5. This is 9 minus 8, 540, that is equal to minus 31. That is d is equal to minus 31, which is less than 0. The given quadratic equation have no real roots. Therefore, the given quadratic equation have no real roots. Therefore, since b square minus 4ac is less than 0, therefore the given quadratic equation has no real roots. Now coming to question number 2, we have solution. We have given 3x square minus 4 root 3x plus 4 is equal to 0. Here a is equal to 3, b is equal to minus 4 root 3 and c is equal to 4. Substituting for d, then therefore discriminant d is equal to b square minus 4ac, that is minus 4 root 3 whole square minus 4 into 3 into 4, that is equal to 48 minus 48, that is equal to 0. The given quadratic equation has two equal roots. Therefore, the given quadratic equation has two equal roots. That is, the roots are minus b by 2a minus b by 2a. This already we discussed in the previous here in case number 3, when b square minus 4ac, in case number 2, when b square minus 4ac is equal to 0, alpha is equal to minus b by 2a and beta is equal to minus b by 2a. That is, the quadratic equation has both equal roots, that is minus b by 2a. Using the same concept, the roots are minus b by 2a minus b by 2a, that equal to 4 root 3 by 6 and 4 root 3 by 6, that is equal to 2 by 3 root 3, 2 by 3 root 3. These are all the two values for the quadratic equation, that is under nature of roots. In question number 3. 2x square minus 6x plus 3 is equal to 0. This is solution. 2x square minus 6x plus 3 is equal to 0. This is the given quadratic equation. Here a is equal to 2, b is equal to minus 6 and c is equal to 3. Discriminant. Now discriminant is equal to b square minus 4ac, that is equal to minus 6 whole square minus 4 into 2 into 3, that is equal to 36 minus 24, that is equal to plus 12, which is greater than 0. The two distinct real x has, then the two distinct real roots are x is equal to minus b plus root d by 2a minus b minus root d by 2a. Substituting the values, that is equal to minus 6 plus root 12 by 2 into 2 comma minus of comma minus of minus 6 minus root 12 divided by 2 into 2 divided by 2 into 2. A further simplification minus of minus 6 becomes 6 plus 2 root 3 by 4 6 minus 2 root 3 by 4. Then further simplify, that is equal to 3 plus root 3 by 2 minus 3 minus root 3 by 2, which are required discriminant values. Coming to question number 2, find the value of k. Find the value of k for each of the following quadratic equation so that they have two equal roots. Find the value of k. So 2x square plus 5x plus 3 is a question 1 under question number 2. Here in this solution, a is equal to here a is equal to 2, b is equal to k, c is equal to 3. C is equal to 3. Discriminant d is equal to b square minus 4ac. b square minus 4ac, that is k square is equal to k square minus 4 into 2 into 3, that is k square minus 20, 2 into 3, k square minus 24. So question itself given have two real roots. That means since the question is given, quadratic equation are equal. Since since the roots of the given quadratic equation are equal. Therefore, k square minus 24 is equal to 0. K square minus 24 is equal to 0. So that implies k square is equal to 24. So therefore k is equal to plus or minus root 24. K is equal to plus or minus root 24. K is equal to plus or minus root 24. Now k is equal to plus or minus 2 root 6. Now this is for question number. K is equal to plus or minus 2 root 6. That is the value for the question number 1. Now question number 2. For the question number 2, kx solution kx x minus 2 plus 6 is equal to 0. Kx x minus 2 plus 6 is equal to 0. Here kx square minus 2kx plus 6 is equal to 0. That implies a is equal to k, b is equal to minus 2k, and c is equal to 6. D is equal to b square minus 4ac. That implies minus 2k whole square minus 4 into k into 6. 4 into k into 6. That is 4k square minus 24k. 4k square minus 24k. According to the question, 4k square minus 24k is equal to 0. That implies take out the 4k as common, k minus 6 is equal to 0. K minus 6 is equal to 0. either k is equal to 0 or k is equal to 6. Therefore, for k is equal to 0, the given equation is not quadratic. Therefore, k is equal to 6. Now, question number 3 under exercise 4.3. Question number 3 under exercise 4.3. Is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 meters square? If so, find its length and breadth. Solution for question number 3. Let the breadth of the mango be L. Then the length of the mango grove will be 2L. Area of mango grove is length into breadth. So breadth is L, length is 2L. Then it is equal to 2L into L is equal to 2L square. That implies 2L square is equal to 800. This is according to the question. L square is equal to 400. That implies L is equal to plus or minus 20. L is equal to plus or minus 20. Now, comparing the given equation with quadratic equation ax square plus bx plus c is equal to 0. Then a is equal to 1. Then a is equal to 1, b is equal to 0, and c is equal to 400. For L square is equal to 400. L square is equal to 400. Therefore, D is equal to b square minus 4ac, that is equal to 0 square minus 4 into 1 into AC minus 400 minus 400. That simplifying, we get 1600, which is greater than, we get greater than 0. Then we can say equation have real roots. Then we can say the given equation has real roots, because here d value is 1600, which is greater than 0. Here b square minus 4ac is greater than 0. Thus the equation has real roots. Thus equation has real roots, and hence the desired rectangular mango grove can be designed, and hence the desired mango grove can be designed for L is equal to plus or minus 20. So we know that length cannot be negative, as we know length cannot be negative. Then taking L is equal to 20, taking L is equal to 20 meter, L is equal to 20 meter, length of, therefore length of mango grove is equal to 2 into 20, that is equal to 40 meter. That is equal to 40 meter. This is question number 3. Now question number 4. Question number 4. Is the following situation possible? If so, determine their present ages. Sum of the ages of two friends is 20 years. 4 years ago, the product of their ages in years was 48. The product of their ages in years was 48. This is question number 4 under exercise 3. 4.3. Now solution. let us say the age of one friend be x years. Let us say age of one friend be x years. Let us say age of one friend be x years. 4 years according to the question. 4 years. 4 years ago. 4 years ago, the age of first friend is equal to x minus 4 years. That is, according to the question, age of second friend plus age of second friend plus age of first friend 4 years ago is 48 is 20 years is 20. The sum of ages of two friends is 20. So age of second friend plus age of first friend is equal to 20. So age of second friend is, what is age of second friend? Age of second friend, age of second friend is equal to age of second friend equal to 20 years minus age of first 20 minus x minus 4, that is 16 minus x years. 16 minus x years. Now, as per the given question, we can write according to the question, product of their ages. According to the question, product of their ages is equal to 48. Further simplification, 16x minus x square minus 64 plus 4x x square, 16x plus x square, 64 plus 4x is equal to 48. That implies minus x square plus x square plus 20x minus 112 is equal to 0. The further simplification, minus x square plus 20x minus 112 is equal to 0. Then further simplification, x square minus 20x plus 112 is equal to 0. X square minus 20x plus 112 is equal to 0. Comparing above equation with quadratic equation, we have a is kx square plus bx plus c is equal to 0. We get a is equal to 1, b is equal to minus 20 and c is equal to 112. Then d is equal to v square minus 4ac, that is equal to minus 20 whole square minus 20 whole square minus 4 into 112, 4ac, 4 into 112 into 1, that is equal to 400 minus 448, that is equal to minus 48 less than 0. Therefore d is less than 0. D is less than 0. Therefore there will be no real roots. There will be no real roots. There will be no real. Hence the condition does not exist. Hence the condition does not exist. Now question number 5 under exercise 4.3. Is it possible to design a rectangular park of perimeter 80 meters and 400 meters square? If so, find its length and breadth. If so, find its length and breadth. Now, solution. Let the length and breadth of rectangular park be L and B. Let the length and breadth of the park be L and B. Perimeter of the rectangular. Now perimeter of the rectangular park is equal to 2 times of L plus B, that is equal to 80. Perimeter of the rectangular is equal to 80. It is given. So L plus B is equal to 80. That implies L plus B is equal to 40, or B is equal to 40 minus L. Now area of rectangular park is equal to L into B, that is equal to L into 40 minus L. Since B is equal to 40 minus L, that is 40L minus L square, that is L square minus 40L is equal to 400. This is given. Now just we go to next page. Next page. Okay, now comparing the equation, comparing given equation with quadratic equation, we get A is equal to 1, B is equal to minus 40, and C is equal to 400. C is equal to 400. Now D is equal to B square minus 4AC minus 40 whole square minus 4 into 1 into 400, that is 1600 minus 1600. Therefore D is equal to 0. So therefore the equation has this equation has equal real roots, hence the situation is possible. Hence the situation is possible. Now the roots of the equation. Now roots of the equation L is equal to minus B by 2A. This is according to the theory. L is equal to minus 40 divided by 2 into A1. That implies L is equal to 40 by 2 is equal to 20. Therefore, length is equal to 20 meters and breadth is equal to 40 minus L, that is 40 minus 20 is equal to 20 meter. Therefore, breadth is equal to 20 meter. Therefore, breadth is equal to 20 meter. Please subscribe. Thank you.